presentation on series of cache addressing nodes. I'm a software engineering student, level 100. What we have right here is a direct mapping. This is a direct mapping cache system. So a direct map cache system is a memory cache organization where each block of main memory can map to only one specific cache line. It is simple and fast, but not very flexible. This is made up of an input bus that accepts memory address from the CPU, address decoders, whose main function is to split address into tag, index, and offset. Index multiplexers, which choose cache lines using index bits. Cache line RAM, which stores data blocks in tags for that line. Comparators, checks tags match for cache hits. Valid bits indicates whether stored data is valid. Control logic decides hits or misses and fetches from memory if misses. Output bars returns the block data or signal of a miss. So basically the splitting address, which is a direct mapping cache, a memory is a memory address is divided into tags, indexes, and offsets. So accessing the cache, the index is used to go straight to the corresponding cache line. The system checks whether it is a valid bit set and whether the tags match. If both match and if both the valid bit set and the tag matches, then the cache is a hit. If not, the cache is a miss and the data is refetched from the main memory. So if a new block maps to a line that's already taken, then the old one is replaced. Simple, but this leads to possible collision. So over here we have the full associative mapping. This is a type of mapping where any memory block can go in any cache line. Address splits into tags and offsets. This setup we see here is made up of cache lines that stores blocks of data and corresponding tags from main memory. Tag fields contain part of the memory address used to identify the memory block. Data field, which holds the actual data copied from the memory. Comparators, which compare the incoming tags with all tags stored in the cache line. Control logic, which manages reads, writes, which manages read write cycles, hit miss detections, and enables cache accesses. Replacement policy. This determines which cache line to evict on a miss, which means which cache line to take out on a miss. We have the valid bit, which flags whether a cache line contains valid data, and dirty bits, which is kind of optional, which indicates whether a cache line's data has been modified. So let's follow the journey of a memory access request. So the CPU sends a memory address. The control logic detects the request and extracts the tag portion of the address. The tag comparison begins. The comparators active and simultaneously compare the incoming tag against all the cache lines. This parallel search is what makes full associative mapping powerful and fast. Checking for the validity. Each cache line has a valid bit. Only lines marked valid are considered for a match. If a valid tagline matches the incoming tag, then it's a cache hit. If not matched, then it's a cache miss. The data retrieval or replacement is when a cache hits. The control logic enables the data flow of the matching cache line to send data to the CPU. Whereas if the cache misses, a block from the main memory is fetched. The replacement policy decides which cache line to evict. The new block start field and data field are updated in the chosen line. The valid bit is set to true. For the dirty bit checks, which is for write back caches, if the evicted line has its dirty bit set, its data is written back to the main memory before replacement. This avoids losing any changes made to the data while it was in the cache. Over here we have the set associative mapping, which is also one of the way of transferring cache files. In the set associative mapping, blocks map to a set of lines. Each block maps to a set of lines. The address splits into tags, set, index, and offsets. This is made up of the CPU address input, which delivers the memory address, which is split into tag, index, and offset bits. The index decoder. This decodes the index bits to select a specific set within the cache. The tag field. This stores the tag portion of the address in each block used to identify if a block contains the correct data. The valid bit. The valid bit indicates whether the data in a block is usable. The comparators, which are they are kind of like what determines the tag matches. They compare incoming tags from the CPU address with the tags stored in each block of the selected set. Also, we have the data block. This contains the actual cache line data fetched from the memory. This is what the CPU wants to retrieve. We have the multiplexer. The multiplexer routes the correct block data to the CPU when a hit occurs. Then we have the hit or miss logic. This determines if a cache access results in a hit or miss by combining the comparator result with the valid bit. And then we have the replacement policies, which selects blocks to evict on a miss. We have the write logic, and this handles writing back data to the memory in case of write back policies. This is mainly when there is a miss. So in the systematic function of this set associative mapping, the address is broken down. So the CPU sends a memory address that splits into tags, index, and offset. Then the set selection takes place. The index bit chooses which set to examine. After that, the tag matching comes afterwards. The tag matching is where the comparators check both ways in the set to see if tag matches any valid blocks. So after that, the data retrieval process is done, then taken into consideration. If the tag matches and the valid bit is a hit or a miss, then for the hit, the cache data is retrieved. If no match, which is a miss, the data is fetched from the main memory and written into one of the replacement policies. So those are the three main ways of cache file transfer within the computer architecture. So we have the set associative mapping, which is this one. And then we have the direct mapping, which is this one. And then we have the full associative mapping, which is this. All these three have their specific advantages and disadvantages depending on, or let me say, based by their ways of functioning, which is very different from each other. Thank you. Now,